Professor Sly qualified in medicine from the University of Melbourne. Amongst his many qualifications, he holds a doctorate of medicine from the University of Melbourne and a doctorate of science from the University of WA. This year he was made an Officer of the Order of Australia in recognition of his huge contribution to paediatric research and education. He moved to Queensland in 2010, and amongst his many responsibilities, he's a paediatric respiratory physician at Children's Health Queensland and the director of the Department of Children's Health and Environment at the University of Queensland. So please welcome Peter Sly.
Thanks, Helen. I am a paediatric respiratory physician. I got into environmental health about 20 years ago, and I was asked to go and give a talk on asthma as an environmental disease. And I was a respiratory physician, and I had actually considered asthma as an environmental disease until then. And this was one of those workshopy conferences you go to that change the way you think about things. And so that's how I got into this area. My background, apart from in medicine, is in respiratory physiology. And so I look at things from a physiological point of view. And environmental health people aren't used to talking to physiologists or clinicians very often. And clinicians aren't necessarily trained at all in considering the environment. So this is something that these are gaps we need to address. In this session this afternoon, I've got some data on the global burden of disease. I'm going to spend a bit of time talking about vulnerability of children to environmental exposures as sort of a way to explain why we need to be thinking about this, and then show you some data on early life exposures and how they increase the risk for asthma and respiratory disease, neurodevelopmental and behavioural abnormalities in children, and obesity and type 2 diabetes, the easy ones. I could also have cancer in there, but I don't do much in cancer, so I'm not going to address that. Right at the end, we should be talking about what you as GPs can actually do about this, how you can engage in this in your practices and help to make a difference. So, towards the end of 2012, these major publications came out in The Lancet that were giving a 20-year update on the global burden of disease. And you have to understand how these things were done. All of these are estimates. They're all done with models. There's very little real data in these publications, and that's one of the things about these global burden of disease estimates is they're estimates. But what they showed was that over the 20 years between 1990 and 2010, globally there'd been a shift away from traditional killers, particularly in early childhood, to non-communicable diseases and injuries. So children were not dying early, but they were living long, and people were living longer with disability. And they introduced this metric in these publications with these years lived with disability. And you can see these are global figures overall. These are raw data. Overall, a decrease in communicable diseases and the traditional killers like pneumonia and diarrheal diseases, and an increase in deaths globally from non-communicable diseases and injury. These are absolute numbers than rates. And yes, they did do the rates and things as well, but the rates have also gone up, and I've got the rates on the risk factors. Sorry? Or down.
And what is early childhood? I should know that, but until which ages does that go actually?
Generally to 5. So particularly in these estimates, they break them up into 0 to 5. That 0 to 5 is also broken down into the neonatal period, your first 28 days, the first year, and then sort of each year. But then 0 to 5 is put together, and then there's 5 to 9, 10 to 14, and then up into the adults, 15 to 18, and then into the adults. So these These are rates or percentages. So in 2010, still 60% of children who died in that under 5 were dying of communicable diseases. But 40% were dying of non-communicable diseases and an incredible 20% dying of injuries. And a lot of these are traffic-related injuries, and particularly in developing countries. But 3% of global deaths from drowning under the age of 5. So if you look at the risk, these major risk factors, and these are now in rates, years lived with disability per 100,000. So these are not deaths. This is the other side of the equation, the people who didn't die. There'd been an overall increase, small, but quite a big decrease in the years lived with disability related to communicable diseases, and increases in the non-communicable diseases, things like cancer, cardiovascular disease, chronic respiratory disease, neurological disease, a whole lot of endocrine things, and mental and behavioural disorders. These had all increased. And if you look at the risk factors, and again this is global, that the overall risk factors for global burden of disease had changed substantially from 1990 to 2010. So in 2010, high blood pressure, tobacco smoke and alcohol use were the major risk factors for disease. They were on the list in 1990, but you can see the orders changed. So child undernutrition, which was the number 1 risk factor for burden of disease in 1990, was down to number 8 with a drop in 60%. Things like high blood glucose, high BMI, big increases. The reason that there's no number against physical inactivity was because it wasn't even considered a risk factor of disease in 1990, and there was no estimates, so there was nothing to compare it against.
Quick question. So is this just for kids?
No, this is for everybody. If you look specifically for children, I may have that slide. I certainly have the Australian slide for Australian children a bit later on, so we can look at those. But this is global. When they do these, they do age standardised estimates and things. But these are the global overall risk factors. So. As I mentioned, the chronic non-communicable diseases, these are the ones that there are definite evidence that environmental factors or exposures in early life play a role. So respiratory disease, asthma and COPD. Now, I haven't got pneumonia on that because it's not a chronic non-communicable disease. That's in the communicable diseases. Also important. Neurobehavioural things, and I'm going to say a little about this later on. So low IQ, ADHD and the autism spectrum disorder, violence and dementia. There's definite evidence in each of these that environmental exposures play a role. You may have heard on the news this week about a cluster of Parkinson's disease, and I can't remember whether it was Queensland or New South Wales, or was it WA? Anyway, somewhere. It was. You're right. It was Victoria, and it was up in the Mallee, and it was in a barley growing area. Now, yeah, that's it. That's it. And now there's well established evidence of early life exposure to pesticides increasing the risk of Parkinson's disease in later life. Nobody has got the link with Alzheimer's yet, but it'll come. So these are all conditions that there are definite evidence of environmental exposures in early life increasing the risk for disease. I'm going to use that term a bit, increasing the risk for disease, because there's not a given if you have an increased risk you'll actually get the disease. There's other factors like your individual susceptibility, which can come from your genetics, the environment that you're in, which modifies the risks, and I've got a couple of examples of that later on, I think. I find this interesting. You look at the economic and social costs of non-communicable diseases, which is not something that we as healthcare professionals usually do. But asthma in the US, $56 billion per annum is spent on asthma. 38 billion on COPD. 60% of the American population, I put this slide together a couple of years ago, is probably out of date now, $160 billion per annum in direct costs to the US economy, and similar things for ADHD and autism. So that the Medicare costs for a child with ADHD or autism spectrum disease in the US are 6 times those of the general population, and greater than the cost of a child who has asthma. So they're not inconsiderable costs, and they're the direct costs. So these are if you look at the total costs of obesity per year, $450 billion per year in the US. 90 billion on people pay more for food because they eat more. 30 billion in plus-size clothing. 20 billion in weight loss programs, which don't work. 20 billion in out-of-pocket healthcare costs. That's not covered by the healthcare system. So their Medicare or their Medicaid pays 60 billion. The commercial insurers pay 80 billion. And then there's a cost to employers, 30 billion in absenteeism, 70 billion in decreased productivity, 30 billion in short-term disability, and it's estimated an extra 20 billion on other things like fuel costs, funerals, because more of them die, electricity. So these are the overall costs of obesity to the American population. Interesting. So these are child data in Australia, and again, these come from this is now 2013 estimates from this Institute of Health Metrics and Evaluation, something like that, which is where the global burden of disease things have come out. And here the data I pulled out, these are hard to get. These are absolutes, they're not rates. It took me enough time to get this to find without finding the rates. So in all ages, behavioural problems are the biggest contributor to burden of disease for Australian children. Iron deficiency is the second common at all ages. Low GFR, and then we start getting things moving apart. High blood sugar, but in the older kids it's sexual abuse and high blood sugar drops down. High systemic systolic blood pressure is higher, a bigger contribution to disease in young children than in older ones. These are Australian estimates. Not using soap for hand washing is on the top 10. Non-exclusive breastfeeding for the infants. Environmental tobacco smoke, and just outside the top 10 for teenagers is unsafe sex. Okay, now I'm going to change tack a little bit, because if we have these ideas of what the risk factors, what the burden of disease are, but we need to be able to measure them. And we need to be able to measure them so that we know whether we're making progress, or we need to be able to measure them so we know what our major problems are. And one of the things that has been, or one of the ways that has been put forward, are environmental health indicators. Now these, an environmental health indicator is an expression of the link between the environment and the child's health, targeted at an issue of specific policy or management, and represented in a form that facilitates interpretation. That's the official definition. So more simply, it's a way of measuring what part of the population or how much of the population is exposed to a various exposure or has a various disease. If it's done in a standardised way, you can compare from one place to another. It doesn't tell you about individuals, it tells you about populations. So, for example, the prevalence of road traffic injuries in children under the age of 5 tells you how big a problem road traffic accidents are. They don't tell you, they do tell you how many people, but they don't tell you which people. So the percentage of children living in unsafe or unhealthy and hazardous housing is an indicator of the health risk from those factors. And so this would come out as 25% of Australian children live in unsafe, unhealthy or hazardous housing. The percentage of children living in households where an adult smokes is another indicator of sort of disease. So the WHO put together a pilot program which has never really been rolled out properly, where they developed a set of 46 indicators in these five main areas, and they did them. They developed them back in the 90s, and so these look more at the traditional environmental problems for children rather than the current ones. And as an example for respiratory disease, you'd have children who up to the age of 14 living in poverty. That's the context. These are then the exposure outcomes, the health outcomes, and an idea of what you could potentially do about them. As I said, there's 46 of these, and don't worry, I'm not going to go through them. But this is an idea. We in Australia don't actually collect our data this way. We had a look, and in Australia we have very good data on outcomes, but a lot of it is a lot of it is not child specific, and generally we have the data for both Indigenous and non-Indigenous children. But with the exposure indications, we actually have very poor data. There are very few indicators on the exposure side where we have full data. There it was not child specific, and there's more data available for Indigenous children than for non-Indigenous children, which is probably not totally inappropriate, but we could probably be doing better. The sort of data, okay, no, that's next. So you then have to ask the question, are these WHO indicators actually relevant to the diseases we see in Australia? And these are, again, estimates, but these are the 2010 data because I didn't have time to update them with the 2013. But these are the biggest diseases in the different ages for the children. And so even though we're in a high-income developed country, things like nutritional deficiencies and diarrheal diseases, lower respiratory illnesses, common infectious disorders are important for our young children. Chronic respiratory disease and asthma as you get older. In the teenagers, mental health and behavioural disorders and non-communicable diseases. So that the sort of conditions our kids have are covered by those WHO indicators, but we don't collect our data that way. We do collect data. In fact, the Institute of, Australian Institute of Health and Welfare, put out these reports every 2 or 3 years, and they group their data differently. So they say, how healthy are Australia's children? And they talk about mortality, morbidity and disability, etc. How well are we promoting healthy child development? And so there are data on breastfeeding, on dental health and on early learning. How well do we go to school? What factors affect children adversely? And it's interesting. One of the first ones they collect is teenage birth. So those data are available. Family and safety. So we do collect data, but it's in a different way. And the problem with collecting data in a different way is then you can't compare it with what other people do. If you collect your own data consistently over time, you can compare how we're doing over time, but we can't compare how we are related to other countries. Whether we should or not, I guess that's debatable. All right, now on to children. So children get their exposures in a number of different ways. The children are different, and obviously transplacental exposure and breast milk exposures are not exposures that adults and older kids have. But dermal exposure, inhalational exposure, non-nutritive ingestion, and that means basically eating dirt from the floor or putting your hands in your mouth, nutritive ingestion. I'm going to show you some data, but in essence, even though that these other exposure pathways are common to everybody, kids get a higher dose this way than adults do. So the vulnerability of children comes from a number of factors. They're growing, they're in an active anabolic state, so that they, per unit of child or body weight, they breathe more, they eat more, they drink more water. They have a higher surface area to volume ratio. Their systems are also tuned for active absorption. You're going to get all the slides, so you don't need to take photos. You can, but you're going to get them all anyway. So toddlers will absorb most of what they take in. And example here, if they take in lead, and there's lead in the soil, even though we're not using it a lot, there's lead in around the old houses in Queensland, all been painted with lead-based paint. There's paint and there's lead in the soil around there. So if a child ingests a dose of lead, they'll absorb 40 to 70% of it, whereas a non-pregnant adult will only absorb somewhere between about 5 and 20%. So even if they take in the same amount, kids absorb more. They're also less well at detoxifying it because their enzyme systems are immature and the blood-brain barrier is immature in infancy, so any neurotoxins are going to have get into the brain more easily and potentially have a bigger effect. So this is the order of magnitude of how much more air kids breathe than adults do. If you took this into, these are minimum requirements, minute ventilation in litres per kilogram per body weight. In the first year of life, kids breathe 3 times as much air relative to their size that adults do. And the same for water requirements and caloric requirements based on their size. So this really does mean that in any given environment, whether it's an air contaminant, whether it's contaminant in water or food or whatever, kids are going to get a higher dose of that contaminant than an adult will. And then there's the other factors. So this is my granddaughter. She's now nearly 8. She was preparing for her 2nd birthday. She's down there on the floor. She's got a hand in her mouth. Just before I took this photo, the foot was in the mouth. There's an apple with a bite out of it. She'll go back to that later. There are various soft toys which get chewed. So everything that's down here on that floor, she's into. We think about airborne contaminants, but there's very little that's actually airborne. Most of it settles and then is recirculated when people or dogs or whatever work through. So most of those supposed airborne toxins are actually down on the floor, down here. And even if Annabelle isn't lying on the floor and she's a toddler, she's walking around and she's closer to that floor than we are. So they get a bigger dose. But actually, and one of the problems and one of the reasons why a lot of this isn't more well known is that exposure assessment in early life is really difficult. Karen's doing her PhD in one aspect to try and improve our methods for exposure assessment. So, why is it more difficult? So that in toxicology, there's a saying, the dose makes the poison. In environmental health and environmental toxicology, particularly for children, that's not necessarily true. The internal dose is often related to the child's physiology. For all of the reasons that I've already told you, you will understand why you cannot extrapolate a dose from an adult to a child. If you do convince parents to let you take blood samples, the sample you get is smaller than you can get from an adult, and there's technical difficulties. Not everything can be measured in urine, which we can collect, although we have had PhD students working on urine analyses, fecal analyses, as to sort of try and get away from needing blood. And also, for a lot of these things that we're starting to be concerned about, the biomarkers are not well established. So we don't actually have one thing that we could say, you measure this and it'll tell you about how much plasticizers you've been exposed to, or you measure this and you'll talk about, you'll be able to see how much of the flame retardants and so on. And classic toxicology is based on the calculation of lowest observed effect level and no observed effect level from short-term studies. And what we now are understanding is these early life exposures are not poisoning events. They are low dose, almost continuous exposures, and that's not, the toxicology doesn't cope with that. And if there's a 20-year lag between your exposure and your development of cardiovascular disease, then no model's going to cope with that. There's also difficulties with starting to understand what's called non-monotonic dose response curves. And yeah, okay. So what that means, a monotonic curve is where as the dose increases, the response increases. And that's, again, what a lot of classic toxicology is built on. The non-monotonic is where you get changes in direction, so like a U-shaped or an inverted U. And what that means is you can't extrapolate the effects of a low dose from a high dose, or vice versa. And if you don't know where you are on the curve, if you think you're making measurements here, you might think that you've got a monotonic curve and therefore it's coming down, therefore lower doses down here couldn't possibly have any effect. These are two classic examples. Bisphenol A has a non-monotonic dose response curve. These are studies done in cell cultures looking at prolactin secretion from cells. And at the lowest dose and the highest dose with the bisphenol, you're getting the same stimulation and less in the middle. Now what that means is there's more than one pathway. There's more than one molecular mechanism in those cells that causes this. And here this one was with DDE, a dioxin pesticide. So here it's the other way around. If you're measuring your concentration down here, you've got a fairly linear thing, but then at higher doses it actually falls off. And so you can't necessarily establish those criteria, Bradford Hill's criteria of causation, where you've got to have a dose response. So if you have a non-monotonic curve, unless you actually understand it, you can't make any sense of a dose response. And in kids, it's also difficult because, as I said, the physiology of a child actually helps determine their dose. And these are data from around the world on bisphenol A in urine. And these were the data that were collected here in Brisbane as kids of different ages. And if you just measure the amount in the urine, you get this relationship. But if you take into account the physiology, as in this is urine flow related to age, little kids actually wee a lot more. And so that if you're measuring this in a spot urine sample and you correct for the physiology, they're actually getting a much, much higher exposure than we would have anticipated. And it's just part of the difficulties of exposure assessment in little kids. All right, now on to some of the disease things. So as I mentioned, there are major environmental contributions to respiratory disease, and in many ways, low lung function is a common link between the risk for lower respiratory illnesses, pneumonia, asthma and COPD. Neurodevelopmental problems, low IQ, behavioural disturbances and cognitive function defects, and I mentioned the obesity and type 2 diabetes. Here it's quite complex. The well-known nutritional link is with growth retardation in utero and then catch-up growth causing obesity. But it's much more complex than that. And there are a group of chemicals which are known as environmental obesogens, and I'll talk about those in just a sec. And what all of this does is it turns out that there's a problem with metabolizing fat. So the intrauterine growth retardation sets up this starvation phenotype and adapts to that. So when they get after birth, if they get into a high-fat diet, they can't handle it. With the chemicals, there's a change in the cellular processes that they end up with more inflammation and can't handle the fat as well, and I'll show something about that in a sec. There are a couple of ways you can get low lung function at birth. You can have exposures that decrease airway growth or exposures that decrease somatic growth. Small babies are going to have small lungs. And there are data on ambient air pollution, so the maternal exposure to air pollution affecting airway growth of the fetus and the baby's size. Household chemicals, there's a great study, long-term study in the UK out of the Avon Valley known as ALSPAC, and they were able to show that women who use more personal care products and sprays and spray cleaners during pregnancy, their children were born smaller, they had more wheeze during early life and higher rates of asthma and lower lung function when they were 8. There is a genetic predisposition. Maternal smoking is a well-known risk factor. Maternal alcohol consumption, data are better in animals than they are in humans, but they're also there. And of course, poor maternal nutrition ends up with small babies. This is important because because of this sort of schematic diagram. Green is normal. So you start off, you have lung growth during childhood, you reach a plateau in early adult life, and then after the age of 40, it's downhill. Some of us are well down this end of the curve. So that's normal. And if you consider that you need, if your lung function drops down into this range, you're going to get respiratory symptoms, and this has been derived mainly for COPD, but it's also true for other things. So you can have early decline, rapid decline, but perhaps the thing that we're now focusing on most is where you don't reach your lung potential. And this is where the environmental exposures really do come in. If you're born with lower lung function than you should have, or in early life the environmental exposures decrease your rate of lung growth and you end up with less, you don't achieve your lung potential, even if you decline at the normal rate, you'll get into that symptomatic zone where you shouldn't. And it's now through a number of big or combined cohort studies been shown that about half of the adults who get COPD get it through a more rapid decline, which is related to tobacco smoke, and about half of them get it through not achieving their lung potential, which is not as related to tobacco smoke, at least personal smoking. Smoking during pregnancy, early life, infections and other things that decrease lung growth, yes, can be exacerbated by personal smoking. But that's why I don't know whether many of you have adults with chronic disease in your practices, but non-smoking COPD or COPD in non-smokers is becoming more common, and this is probably the reason for it, or one of the reasons for it. So environmental risk factors for respiratory disease, we probably know about most of these. Tobacco smoking in our part of the world is still the biggest one. Globally, it's biomass fuel from heating and cooking, and it might surprise you to know that about a third of the world's population relies on biomass fuel for their cooking and heating. And what really blew me away, and I was in India towards the end of last year, about 25% of their highest quintile of wealth in India relies on biomass fuel, or use a lot of biomass fuel, and they've got more billionaires in India than any other country, and yet these exposures are still occurring. So tobacco smoke, indoor air pollution, outdoor air pollution, traffic-related pollution, industrial pollution. Diesels are especially bad, and they reckon it's going to take more than $10 billion to fix the Volkswagen problem, and if they take into account long-term lung disease, it'll probably be 10 times that. But also contributory factors like diet, nutrition and poverty, and early childhood acute respiratory illnesses magnify all of these. So that if you've got a child who's living in a rural area where there's, or it doesn't matter where they're living, where there's overcrowding, where there is biomass fuel for heat or cooking, and the parents smoke, and there's poor nutrition, sort of all of those things magnify, and that's there's still a lot of that goes on, and there's quite a lot of that in our country too.
Are there any protective factors?
Yeah, there are protective factors, and the protective factors really come down, and hopefully I'll get into that a little bit later, but things like good diet, so antioxidant in the diet, so fresh fruit and vegetables, less processed food is probably the biggest thing. Exercise, not just from an obesity point of view, but from a general. Yeah, green space. Yeah, green space is interesting. It depends where you are. Green space in Brisbane is probably pretty good. Green space in India isn't actually green space. It's covered in dust, and in fact, there are now people are starting to write papers about the pros and cons of green space. You can't walk through a park in the US at night. You get mugged. Sorry.
No, finish
Yep.
first and then I ask a question.
Yeah. No. So yes, green space, and that comes from there's lots of potential things, psychological benefit of a nicer environment, trees that sort of put out oxygen and in general help clean up some of the contaminants in the air. So yes, there are lots of benefits. So they're the main mitigating factors, but nothing beats preventing tobacco smoke exposure. Sorry.
What about burnout? I mean, we have.
Yeah.
I mean,
Yep.
every second
Yep.
there's the burnout in my area, and it really you don't want to go outside.
Yes. Yeah, the departments of, in Western Australia it was Conservation and Land Management, I'm not sure what it's called in Queensland, the one who's responsible for these things, they argue that if they burn off properly, then you don't get the big bushfires, and a controlled burn off is overall better than a big bushfire, but they always seem to get it wrong. Yes. And yeah, certainly the wood smoke from that is the same sort of stuff. It's full of polyaromatic hydrocarbons, the particulate matter. It's not as it won't have as many of the things like transitional metals and things like that because it's of how it's made. It's just timber and trees and brush. But yes, that's also hazard, particularly for people with established disease. So that's. I got my Brisbane City Council newsletter yesterday, and they're talking about controlled burning, and they say yes, we do it when it's safe, and when the weather forecast. And if you want to know when it is, there's a website you can go onto. A bit like the weather forecast that says possible showers in Brisbane. As I said, every day for the last 2 weeks, and I think we've got one day. So they're not very accurate. What they really, a good positive public health type thing here would be alerts for asthmatics or people with chronic respiratory disease that make sure you've taken your medication today because we're going to burn off. And that service, to my knowledge, doesn't exist, but it could. All right, so just to finish off on the lungs, we've proposed that chronic lung disease exists on a spectrum. So you start off with a shared risk type, which is probably genetic, plus or minus environmental, and then depending on what happens is what sort of lung disease you end up with. If you have the type of genotypes that are likely to give you early allergic sensitization and you get lots of respiratory infections, you may end up with atopic asthma. If you have not the atopic phenotype but get fewer infections but still frequent infections, you may end up with non-atopic asthma. And if you have less intense respiratory infections, other inflammatory things, and you start smoking or other things, you end up with COPD. So that this is, we put this together as an attempt to try and explain why different sorts of exposures end up with similar clinical outcomes. I'll move on. So neurodevelopmental. We know, and there are good data to show that you get decreased IQ in the offspring if they're exposed during pregnancy to lead, to polychlorinated biphenyls, maternal smoking, mercury, as in like in big fish, alcohol, maternal infections and severe maternal malnutrition. Each of these has been shown, or apart from the severe ones, has been shown to cause a shift of about somewhere between about 5 and 10 IQ points, which might not mean much to an individual. If my mum didn't smoke during pregnancy, which she didn't, I might have won a Nobel Prize by now. But on a population basis, that's bad for me, but on a population basis, and this is a population the size of the US, your average IQ is 100. That means you've got 6 million up in the gifted range and 6 million down in the mentally retarded range. A 5-point shift, yeah, he's down this end, definitely. A 5-point shift in IQ drops your gifted population down to 2.4 million, but increases your retarded population up to 9.4 million, and with sort of the health burden. A 5 IQ point shift on a population the size of the US. Maternal smoking is estimated at about 7 IQ points, lead at about 7 to 10 IQ points. So these are not, on a population basis, these are not trivial. These are the original data that showed connected lead to behavioural problems in children, and these were done by measuring lead in teeth in the kids, and essentially this is the higher, as you go up these graphs, you've got more lead in your teeth, and for all of the behavioural problems, the distractibility, hyperactive, frustration, impulsive behaviour, they were higher as you go up with more lead. Sorry?
Isn't it fair to say that all of our age group were affected by lead because of lead and gasoline?
Absolutely.
Lost 5 points or so?
Absolutely.
Yeah.
There's a very, very, they took lead and gasoline out of gasoline in the US 20 years ago, 25 years ago. And there's a great publication written by a lawyer who has tracked the fall in the population blood lead levels in the US, where they do biomonitoring, and overlaid it with a 20-year lag of violent crimes, including gun, murder by shooting, and there's a pretty good match. Yes, we were all affected by lead, and still are. These data from Canada show that there's no such thing as a safe blood lead level. And what this shows, this is IQ against blood lead. And in fact, the steepest decrease in the IQ occurs at the lower doses. Now that may mean that there's a limit to what you can actually lose, and from here up it doesn't make any further difference. But it does so that there's no such thing as a safe blood lead level. In Australia, I think we're down to 7 micrograms per decilitre at the moment. Maybe we're 10. Sorry? Oh no, I'm talking about what the limit is. They dropped it to 5. The US, the CDC have now come out and said they couldn't say there was no safe blood lead level, but what they have said is that the actionable lead level, where you should be actually thinking about chelation or other treatment, is if the blood level exceeds the 95% percentile of the population. And currently that in the US is about 5. In Mount Isa, there is a considerable problem. In Port Pirie, 20% of the kids have blood lead levels over 20, and it's bad. I mean, and this is in a high-income developed country, and we allow that to happen. Anyway. So what causes these problems? The flame retardants, PBDEs, polybrominated diethyl ethers. PCBs are old polychlorinated biphenyls, which were never made in Australia, but every one of us has a PCB blood level. They're very long-lived chemicals, and essentially we can't metabolize them. So babies who are born, there's a couple. The knocking down of the Twin Towers gave us some really good experiments. So babies who are born with increased cord blood levels of these flame retardants have more ADHD. The same for these PCBs, phthalates, which are plasticizers and the things that line cans, lead, pesticides. So we knew about it before the cluster was announced. So they're all there. I like to.
Phthalates are in the little, when you buy a Diet Coke or something like that. That's
Yep.
in the plastic can.
It's in the plastic. It's in the lining of the can. Yes, yeah, in pretty much all canned food. There's also lots of other things as well. Phthalates are the soft plastics, right? Yes. So rubber duckies full of phthalates, there's lots of things. I like showing this slide. These are data from an agricultural area in Mexico, and the kids. The main market gardens were down in the valley, and kids who lived up on the foothills were much less exposed to the agricultural pesticides. So these were the 5-year-olds were asked to 4.5-year-olds were asked to draw a man, and see these are male and female that are living on the foothills, and these are the female and male living down in the valley or exposed to pesticides when they're asked to do the same sort of task. Now, obviously this is a very dramatic example, but there's lots of data that support this and show that this is not just a trivial problem. So, obesity, environmental obesogens, what are they? Well, that authoritative source wiki describes a obesogen as a xenobiotic that disrupts normal development and the balance of lipid metabolism. So that's an obesogen. So there are a lot of potential chemical obesogens, and there are data from animal studies, but also from human studies the PBDs and phthalates are down here. Maternal smoking during pregnancy is a big risk factor for obesity. Pesticides, flame retardants, nicotine infusions in animals, BPA. So these things, perfluorinated compounds, so the things in your Teflon non-stick fry pans. But there's one of the reasons why people can be quite sceptical about this is that, these chemicals are lipophilic. If you're fat, you've got more fat, therefore you're going to have more lipophilic chemicals in your fat. So is it a cause or is it an effect? The data that made me think there was something in this are these. These come from the NHANES, and these are in women in the US, so they're population biomonitoring. And what they did was they measured 6 persistent organic pollutants, and these are from the lowest to the highest quintile. They stratified people related to body mass index, and this is the prevalence of diabetes. If you were the people who were in the lowest quintile of the chemicals had no obesity. Thin people, prevalence of diabetes increased progressively as the more chemicals in their body. And if you had both, then the prevalence of diabetes goes off the roof. So it's not causative information, but it makes me think that there's more to this than just more fat, more chemicals. So what do? These environmental obesogens have their major effect in early life, during development. They affect adipocytes, and particularly the adipocyte precursors. They also are likely to impact on the gut microbiota, both in the mother and also in the child, and we'll talk about that in a minute. And it's thought that they have effects largely via epigenetic modification of gene expression, and also can have some effects in the brain, so that they can alter your sense of when you're full, so that so that people don't know when they've eaten enough. There are some data in animals that are reasonably convincing, and so the way these work, they start off with a mesenchymal stromal cell. They become pre-adipocytes, which then mature into adipocytes, and this process is dependent on this pathway. If you have environmental chemicals, and here EDC stands for endocrine disrupting chemicals, and there are some examples here. it's been shown that these can lead to more fat cells. So this particular group increased the pre-adipocyte production, and this one increased adipocytes. So you end up with more fat cells. They also change the way the cells metabolize fat, and so you end up with a more pro-inflammatory fat cells. Now, you've probably read that obesity is an inflammatory condition, and that there's thought to links between obesity and some of the other conditions like asthma might be related to these inflammatory mechanisms. Well, these chemicals can set up the way the fat cells metabolize fat and produce more inflammation. These come through activating the aryl hydrocarbon receptor, which is a common receptor that in a lot of environmental chemicals attach to. And the effect is more profound in the precursor cells. And they know in the mice that this is through the aryl hydrocarbon receptor by blocking it, or by using knockout mice and eliminating the effect. So these chemicals can alter the metabolism and storage of fat. There's a fascinating study with bisphenol A in rats, and basically they showed that if their mothers were given exposed to the bisphenol during pregnancy, that the pups had more, were heavier, had more fat, had insulin resistance and glucose intolerance when they grew up. And these effects were exaggerated if they were fed high-fat diet after weaning. But in this study, it also showed that this could be prevented by exercising the pups from a young age, so that exercise can actually change the way that fat's metabolized, not just burn it off. And so obesity is much more complex than too many calories in, too little energy burnt out. I'm going to say a couple of words about the gut microbiota, because again, this is something that we can actually interact with. So we all know that we're full of bacteria, and the bacteria in our bowel are responsible for what's called peripheral metabolism. So a lot of the fatty acids that we have, we can't make. We rely on the bacteria in our bowel to actually be able to generate those, and these come from the food we eat. The bowel is thought to be sterile at birth, and the acquisition of the microbiota comes fairly quickly afterwards. It's influenced by the mode of delivery. It's influenced by the maternal microbiota. It's influenced by feeding practices, breastfeeding, weaning, whether you've got other siblings, whether you've got pets. There's all those things influence the developing microbiota of the child. And we have this sort of belief that there are beneficial microbes and pathogenic microbes, although we don't actually know what does what. And it's really difficult to be able to be certain. We know that so-called beneficial microbes can decrease the risk of childhood obesity and of asthma, but we don't necessarily know what they are. Dysbiosis is the term that's used when there's an alteration of the normal microbiota. And if it can happen through taking antibiotics. The Western diet, which is not high in unprocessed foods, fresh fruit and vegetables, but higher in salt and sugar and fat, alters your microbiota. Maternal disease, obesity is classic, and if the mothers gain a lot more weight during pregnancy than they should, their child's microbiota is different as well. So it's weird, but it's complex. But the microbiota interacts with the environmental toxins. So the bacteria can detoxify or can make chemicals more toxic, depending on how they metabolize them and depending on what's in the bowel. And that's part of the reason why it's really difficult to know. This was an interesting study as well, where they gave maternal pregnant rats PCBs, and it changed the abundance and composition of the microbiota in their offspring. But then if the offspring exercised, they could actually reverse that. And so exercise having an effect on the gut microbiota, I mean, who knows how that could possibly happen. Just a couple of data slides. Obesity starts early. Big studies in the US essentially show that if kids are overweight on entering kindergarten, then they're four times more likely to become obese. There are similar data in Australia, so that in our longitudinal cohort studies, we don't see kids very often becoming fat. They're either fat to start with and then we follow them through, and that seems to be, this is an early life phenomenon. Now that's obviously not absolute, but that's the most common. These are the data from this ALSPAC study and the risk factors for obesity in 7-year-olds. In this study, they had 8.6% were obese. They identified 25 risk factors, and these were the top of them. Parental obesity, parental smoking during pregnancy. I mean that's really the big one. Maternal smoking during pregnancy. The bigger the baby was, the more likely they were to be obese. If they're in the highest quartile of weight at 8 months or 18 months, then they were increasingly likely to be obese. If they were born small and then had catch-up growth, so you're getting the flavour here. There's a U-shaped curve between birth weight and disease risk. If you're the right weight, you've got the lowest risk. If you're underweight or overweight, you have an increased risk of lots of diseases. This adiposity rebound just means that you didn't have much fat as part of this catch-up growth. So weight gain during the first 12 months, then things like time watching TV and short sleep duration. Now, I'm going to say about this in a minute. It's not quite what you think it might be. Short sleep duration is a really interesting one, and it's becoming more accepted that kids who don't get enough sleep have the increased risk of all sorts of diseases. So antibiotic use in early life, small but significant increase in fat mass with the antibiotics in the first 6 months of life that persists. The effect's not as great if it's given later in childhood, and almost non-existent if it's given after sort of 18 months of age. So they're very early. Maybe this is an effect on the developing microbiota. Other things from the ALSPAC study: exclusive breastfeeding is not protective of obesity. Early menarche. An increased associated with an increased BMI in childhood, and you don't know what the cause and effect is here. Yep.
What is that like exclusive breastfeeding in brackets? Is that 2 months? Is it?
Yes, in the ALSPAC study, that was that. So that was. This is a Avon Valley longitudinal study of parents and children, and so they got all of the births in the first 2 years of the 90s. And enrolled them in the study, and so that then they will have looked at various times that people stopped breastfeeding. But in this particular study, if you breastfed for 2 months, there was no protective effect. There wasn't of longer times either. Okay. Yeah, but that was in this study. Increased energy-dense, high-fat, low-fibre diet associated with increased fat mass. Well, not much surprise there. But one of the things that's obviously popular in that part of England is flavoured milk. And so that you could see that the kids who had, it was more of an effect in girls, but the kids who drank flavoured milk had more fat mass than those who didn't. Caesarean section, again possibly a microbiota effect, magnified by being a child of an overweight mother. In normal weight mothers, basically no effect. Exercise and obesity. There are 2 studies, data that suggest that obesity causes low activity. And there might be a number of reasons for that. In this particular one, what they're looking here is fat mass index, which is an index of adiposity, and activity. And the Z-scores, so a minus Z-score is where you have below average activity. A Z-score is a standard deviation score. So the kids who had moderately vigorous exercise in this study of obesity and TV watching, where they measured genotypes in 5,500 and fat mass in 4,000. They had 21% were overweight, 4% were obese. They said in general boys were more active and less sedentary, but even then when they looked through here, there was not moderately vigorous activity was associated with a somewhat lower fat mass, but not significant. And again, was just slightly significant, and the sedentary time was increased with associated with increased fat, but not as much as you might think. And in this one, where they looked at genes and calculated a weighted score for genes that have been associated with obesity, they decided that there was strong evidence for adiposity reducing physical activity. They don't know why, but it just seems that we sometimes, when we have an idea of which way something is, the causal pathway is running, it's not always right. And this may partly explain why exercise programs don't work in obese, and there's never been a really successful, sustained intervention related to exercise with obesity.
Although having said that, there is some evidence that once you've lost the weight, being active
keeps it off. Absolutely, yeah.
Would feed into that.
Yes, it would. So you can sort of put this together, something like this for the obesity thing. We've got prenatal exposures that can affect the developing adipocytes, with it resulting in increased number, pro-inflammatory profile when they and altered the way they store lipid. Prenatal impacts which cause dysbiosis in the maternal gut, which in turn passes on to the infant's gut. Exposures during pregnancy. Exposures in early life, and through these same mechanisms can result in a very complex factor, but it boils down to prenatal exposures, smoking, chemicals, oxidative stress, toxicants, poor diet. Maternal obesity is one of the big risk factors, and then environmental exposures in early life. So what can you do about it? First of all, recognise that there are environmental contributions to disease, and that's the big one. Take an environmental history, and I'll give you a very vivid example from my own practice. In Western Australia, I was referred this 4-year-old girl who had these very acute and severe exacerbations of asthma, ending up in the ICU, only ever occurred in summer. And most of the rest of the time her asthma, she did have asthma, but it was mainly reasonably well controlled. And we couldn't work out what it was. And then I started asking questions. And essentially it boiled down to the fact that a family grew table grapes in the Swan Valley. And depending on the weather, they would take sulphur powder and fling it around on the grapes to stop mildew. And now the girl wasn't out in the paddock doing that, but she was in the shed with the father when he was making it up, and it was the sulphur that was triggering her acute asthma. And once we realised that, and sort of put in some sensible controls that should have been there in the first place, she didn't get up in ICU again. So take an environmental history. Smoking. It is still the most preventable factor that we can do, and it will have the biggest impact on decreasing disease. And it really, if you don't know your families really well or your patients really well, asking them, are they smoking, is really something that every GP should do. I'm not saying you should do it every time, because if you know them, you can ask. You'll know. But other things like household chemicals and pesticides and garden chemicals. The diet and food preparation practices. So heating.
So which household chemicals should we be?
Well,
there's a lot of them around.
Yeah, there are. It's basically the spray products, things in cans that you spray. They're worse than the ones that you put on surfaces and wipe off. But most of these cleaning agents you don't need to use at all. And pesticides. Karen's done quite an interesting look at how kids get poisoned in our homes from the Poison Centre, and all sorts of weird and wonderful things like snipping off the flea collar and fitting it to the cat, but dropping the end on the ground that the kid eats. One child squirting the pesticide into the mouth of the other one because it wasn't in a child-proof container.
My favourite one was the child for multiple children, 20 children actually, eating dead cockroaches or geckos that had been sprayed with the pesticide spray. Because if you watch those ads on TV, they often spray an insect and then there's no video or part of where they pick it up and put it away or put it in.
Anyway, but the other one that people don't often think about is occupational and so-called take-home exposures. People who work in the city spraying in the gardens, when they go home, that stuff's all over their clothes, and so their kids are going to be exposed to this when they go inside. You don't generally strip off outside, and of course noise and traffic-related pollution. There are, we haven't got time to go into it now, I know, but there are ways you can avoid these exposures. You can avoid the exposures to plasticizers by not heating stuff in a microwave. Baby formula, glass is fine, yeah, absolutely. Baby formula, people have to heat it in the bottle. Babies don't need their formula heated. Yes, breast milk is at 35 degrees, 33 degrees, but babies very quickly learn to drink their milk at room temperature, their formula at room temperature. They don't need to be heated at all. And sort of not having things in child-proof containers. So there are ways that you can avoid exposures. Things that people don't necessarily think about. Mosquito coils. Lots of people still use those in Brisbane. If one mosquito coil will put the same amount of formaldehyde into a room as burning 50 cigarettes. It will put a large number of inhalable particles, because the smoke you can see is not the bad stuff; it's the stuff you can't see.
If these things were pharmaceuticals, they probably wouldn't be allowed to be prescribed.
Absolutely.
Why aren't we banning these things?
Well, there's a very simple answer to that. There's something like 3,000 or 4,000 new chemicals introduced each year. 3 or 4 of them have probably been tested for health effects. The rest of them are covered by commercial and confidentiality. And the best example is bisphenol A. Now every baby bottle's BPA free, proudly labelled, but it's still made of polycarbonate plastic. It says BPS or BPF or other BPs. You cannot make a polycarbonate plastic without a bisphenol. You can make PET chemicals without a bisphenol, but if they're exposed to UV or heat, they release cadmium, and that's not so great for you either. But we're not allowed. They don't have to label these things.
What about children's lunchboxes then?
The main problem comes from heat. So a children's lunchbox that if they left it sitting in the sun, and the plastic, then the stuff inside is going to be you're going to get some of the chemicals in it. But if it's inside and if it's in the cool, you don't get that much transfer at low temperatures. The things that increase transfer are heat and acidity. So you put acidic things in plastic, then you're going to get more leaching, and if you heat it, you're going to get more leaching. So the cool lunchboxes, where you put the thing. No, the one that you freeze the little brick and it goes in the outside of it. So that's a cool lunchbox. There'd be very little transfer from the plastics from those. Sorry. Sorry. Fat, yeah. Fat lipophilic does increase the transfer, but again, it's probably not as bad as heat and acid, but it is definitely part of it. Sorry, I've ruined your afternoon. Sorry.
You never mentioned about electromagnetic waves.
No, I didn't. There's lots and lots of other things I could have mentioned. One thing that there is increasing evidence. EMF is very controversial, and it's hard to measure. The best data though related to EMF, it was with mobile phones, and it certainly shows an increased risk of brain cancer, solid brain cancer, in kids or in people who started using mobile phones before they were 15. And so it's on the side that you hold the phone on. And so doing things to decrease that direct exposure. Fortunately now kids text more than they speak on phones, and so that's down here, so that risk may be not as much. The EMF from overhead power lines has been very controversial and very difficult to get any definitive evidence one way or the other. There are believers and there are skeptics.
Well,
Sorry.
thank you very much. That was incredibly illuminating, but I think he's got to keep working. There's a lot more to find out.
That's why I've got people like Karen doing a PhD. She's going to come up with an app or a program that parents can use to assess their homes, and it's going to then give suggestions as to how they can avoid some of those exposures.